instrument. So, to give you a quick overview of who are involved in this project, I come from the URV here in Tarragona in Spain. We have IMM and Adnagen in Germany, IMEC in Belgium, MRC Holland, which is a specialist of PCR and MLPA in Holland, and we have also a hospital in the Radium Hospital in Norway, and Fuji Biodiagnostics in Sweden, who worked on the development of new cell markers. You can find us, if you need some more information or want to contact us, on the IMEC website under this page. Okay. So I'll start with the cell isolation and detection. In terms of cell isolation, if we start with a blood sample, typically 1 milliliter volume, you'll find that you have around 5 billion red blood cells mixed with 5 million white blood cells, and maybe, if you're unlucky, you have 1 cancerous tumoral cells. So we need a really good system to be able to discriminate between the healthy and the largely present healthy and the non-healthy cells. This is achieved, as I said, by the magnetic beads, which are labeled with some surface antibodies, able to bind very specifically to the tumoral cells. By applying a magnetic field, we are able to extract those healthy cells or irrelevant cells, if you want, and then we are left in the sample with the excess of beads, and the ratio of beads to cells was an important parameter in the efficiency of this approach. We are then able to isolate the labeled tumoral cells, discarding the single magnetic beads, and then should be able to count those cells and say how many were there. So here, an artistic view of the sample incubation module. What you see here is the mixing chamber with the paddle wheels, where the beads and the blood samples, typically between 5 and 10 milliliters in volumes, are placed together and left to interact. This is the real things, the paddle wheel mixer here. We then have the microfluidic chip and a movable magnet and a slide valve that enables us to trap those magnetic beads onto the bottom of the chamber, and by actuating the slide valve to transfer those isolated cells into the cell sorter. The cell isolating and counting, well, we take advantages of magnetophoresis. Basically, we have, if you see here, coming out from the isolation module, the incubation chamber into the fluidic chips, you see here a schematic representation of the device. We have inlet 1 where the cells and the particles come in, and by applying different fields, we're able to drive the single magnetic beads in one direction while driving the complex cells beads into another. So if they both enter in that end, by applying different fields, we're able to drive the single beads down this end, while the complex cells beads are driven into the next step, the next module. Here's some. So to achieve this magnetophoresis, we have a 4-phase repeating ring conductor. That is a planar device, and by switching fields between each of those electrodes, what we're actually doing is pushing the beads or the complex beads from one electrode to another. So basically hopping from one electrode to the other. Here is a few photographs of how we can drive, how efficiently we can separate those cells. We have here the complex cell bead coming into the chamber. The flow is vertical from up down, And by applying the fields between those electrodes, actually, the complex is driven to the right. If we only have a single bead that is not complex, because the field applies are very selective to this system, the single beads are just driven straight through the channels. So here we coming out of this module, we have some isolated cells. We now need to extract those, amplify the. It's coming off.
5 minutes. 5 minutes.
Same for the amplification is fairly complex. With the partners have worked on the elucidation of 21 genetic markers, 21 sequences. Like you can see, here, target 1, 2, up to 50. Amplification allow us to amplify those 20 targets at once. Nice in a test tube. No, it's okay. Shall I take this off? Okay. This is nice in a test tube, but we wanted to do it on a chip. So IMM device design is very nice, the chips, so we are able to see if we have the sample coming out of the cell sorter. It's heated to denaturalize, to break the cells, and following amplification, we have our samples ready for detection. There's the detection. So the detection, we choose to design an electrochemical biosensor array.